So now that you have your data written, first question, our first example of how we're going to use comparison statements says, how many coast redwood spreads does it take to equal the spread of the white oak? So we're looking at the coast redwood spreads and the spread of the white oak, and here's our measurement for spread in our final column here. So the coast redwood has a spread which is equal to 80 feet. And that's a measurement of diameter, right, if we refer to that. And our white oak spread is equal to a diameter of 119 feet. Okay. So it says, how many coast redwood spreads does it take to equal the spread of the white oak? Well, it's asking you how many times does the coast redwood spread fit into the white oak? How many times can you put it in there? To me, that's division. So 80 divided by 119. When you write division, you're actually writing a fraction, correct? So we could write this as a proportional statement, but it's actually asking for an answer. It actually wants to know how many coast redwood spreads does it take to equal the spread of the white oak. So 80 goes into 119 once, right? 80 times 1 is 80. When you do your subtraction, 9 minus 0 is 9. 11 minus 8 is 3. We have 39. If you want to put the decimal there, I would recommend it because we're going to need a 0. So bring down the 0. 80 goes into 390 4 times, and that gives us 320. So you subtract, and we're left with 70. And bring down another 0. So 80 goes into 700 8 times, and that'll give you 640. At this point, I would say you can stop. You've got 2 decimal places, so your answer would be approximate, so you would have kind of a wiggly equal sign, approximately 1.48. So the final stage of this video lecture is going to be when you're thinking about a problem and it requires comparison of counts or measurements, how do you decide whether to use differences, ratios, fractions, or percents? So for the most part, if you have a relatively small number, like our first example comparing 3 to 2, you can choose to write that ratio however you want. A fraction, a proportion, just a simple ratio, anything that's common to the average person's mathematical knowledge, right? You're not going to be looking to create a grandiose ratio. So if you have very large numbers, like the numbers that we looked at for the bulletin board project, right? When we looked at people comparing Macs to PCs, and you said, okay, with 17,000 something compared to 5,000 something. Those are different, those are very large numbers. Can we simplify them down to a simpler ratio? The other thing, so the first instance you want to really look at is the size of the numbers, or the quantity of the numbers. The second instance you want to look at is what is the denominator? The denominator is going to tell you a lot. So if you can write the fraction in terms, if you can write the ratio in terms of a fraction, the denominator is going to tell you a lot, because if the denominator is a factor of 100, so is it a factor of 100? Meaning, does it go into 100 evenly? If it is, then you can easily write the ratio as a percent. Percents are great to use because everyone knows what a percent means. Everyone knows that a percent is out of 100. So if the denominator of your ratio statement is a factor of 100, and you can find a magic wand that will easily multiply your ratio to give you a number out of 100, or to give you a percent, using that is going to really influence a consumer, really influence somebody looking at an advertisement or looking at some data in terms of using that for their advantage. So in terms of a difference, we just introduced a difference today. And when you're looking at a difference, it's really almost a last resort. So a difference statement is a last resort. And the reason I say that is because if you can at all simplify a fraction, if a fraction at all can be simplified, meaning there's a magic one that is a factor of both the numerator and the denominator, so you can shrink it down to something in simplest forms like 3/2 or 3/4 or 5/6, that's relatively small, you want to do that. If you can't simplify the ratio whatsoever, you don't want to have these really difficult numbers to work with. For example, if you had a prime number in your ratio statement, if you had, 27 compared to 11, those are still relatively small numbers, but one of them is prime, so it's never going to be nice and even. That's a situation where you could use a difference statement. So 27 minus 11 would give you 16, so you say, okay, 16 more people prefer blah, 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 however, whatever item you're comparing. But again, a difference is really a last resort. It's not mathematically intuitive. People have to do the calculation to understand it, so it's not really great for sales or marketing and those kind of outlets. Okay, so any other thoughts you have about using differences, ratios, fractions, or percents, go ahead and jot them down in your notes. It's only going to help you next week when we get into our stages, and it's going to help you to influence those ideas into your classwork and into some of the more complicated problems that we're going to be seeing next week. Okay? So happy Thanksgiving to everyone. I hope you enjoy your long weekend, and I hope you weren't completely overwhelmed by our slightly extended lecture. Happy Turkey Day!